Good evening, good afternoon, good morning, wherever you may be watching this from. This is nice to be now with another video. Now we continue from where we ended, that is, now we'll go to addition of vectors. How do we add vectors? Addition of vectors. We'll look at two main rules, two methods rather. So two methods. There is the parallelogram rule, and then there is the tip or the head to tail rule. So there are two main methods of adding vectors, the parallelogram rule and the tip or head to tail rule. I'm going to just give examples. I'm not going to give any worked out examples. I'm just going to explain how we do this if we were to be asked in a question. So given the vector, maybe we can have position vectors. So position vectors will be talked about in our next video. But if you have a position vector O, OP, and then we have another vector O, W. So OP and OW. So these are two different vectors, and then they tell you to add them. What you do is you get the OP. Usually you start with the vector that is pointing up. So that's the OP right there. And then you get your OW. It's going to go like that. So to add them, what you're going to do is this vector, the OW, here, is going to come up there. So this is going to be brought onto there. This onto there. The same length. Then, let me repeat that one again. This onto there, onto the top. And then this one here is going to be dragged. It's going to be dragged. I don't know if that makes sense. It's going to be dragged like that, pushed. This length here, you're also going to put it there. Sorry. Now what we have done is that we have drawn a parallelogram. These two sides are parallel. These sides are also parallel. Those arrows are just indicate that they are parallel. Alright. We can remove them so that we do not confuse ourselves. So what am I trying to say? This OW on top, it's now also OW. This OP, this side is also OP. The resultant vector will be the vector that goes like that, right in the middle. We can call it this point, I don't know, we can call that point X. The resultant vector, this will be C. So how can we get the resultant vector? We add this and that. So it's like we move from this point, we're moving like that, and then we go there. We find ourselves at X. That's the first method. Or we are moving at this point, we go like that, then we go like that. That's the second method. So this is the parallelogram rule. The second rule will be explained in the second video. Recap of what we have learned. OP was like that, OW was like that, OP was brought there, OW was brought down there, OW was brought up here also, OP was dragged same length there. Why are we doing this? We are doing this to create a parallelogram. Now you can use a compass for this. That is more applicable in physics. Mathematics, we would know the exact length of this, so even the way they are moved according to the x coordinates and the y coordinates, we would know and would not make any mistakes. So this vector that cuts the middle of these two that you are adding, so it bisects, it's in the middle, it bisects them. That one is the, okay, one thing we have to note, it doesn't always bisect, sorry. It is at a certain angle. We can use the cosine rule here. Let me not confuse you, but just know that this one that is somewhere there, coming out like that, somewhere in the middle, it doesn't always bisect, it's at an angle. Somewhere there, that is the vector. So thank you so very much for watching. This has been Cornelius Linda. Bye bye.